If you've been following this channel, you'll know that we love vector proofs. And today we have another really good GCSE vector proof to look at. So in this question, we want to prove that AMC is a straight line. We're thinking about other vector proofs involving straight lines. We're going to want to show that AM, the shorter part of this line, can be multiplied to find AC, the longer part. So let's start off then with finding this vector from A to M. So we want to find AM as a vector. And if you start at A, well, we could go from A to O. So let's write A to M, we can do A to O. The next part of our journey would have to be going from O to B. So plus O to B. And the third part of our journey would be going from B to M, plus BM. Well, let's keep it going then. So we're also told M is the midpoint of QB. So actually we can replace our BM with still an A to O, still an O to B, but instead of B to M, we can say that's a half of B to Q. So plus a half BQ. Now let's sort this thing out. So going from A to O is minus 3A as a vector. So we've got minus 3A. Going from O to B is just B vector. And then we're going to do plus a half. And now let's consider the vector B to Q. So to go from B to Q, you'd have to go a minus B back to O, and then plus 4A to get to Q. So minus B plus 4A. And sorting all of these vectors out, expanding our brackets, we've got minus 3A plus B minus a half B, coming from the half times minus B. And we're also going to have plus 2A, because we had a half times 4A. So simplifying, we've got 2A and a minus 3A. So we've got minus A plus a half B. That's because we had B minus a half B. So that was our vector A to M. Now let's consider our vector A to C, which is actually a little bit easier to find. So I'm going to switch colours to go from A to C. We want to go first from A back to O. So we'll say A to O. And then second, we want to go from O along the top to C. So A to O is going our minus 3A vector. And then O to C, well, we go B and another half B. So that's plus 3 over 2B. Or 1.5b. This looks pretty good for us at the moment because we have A to M is minus A plus a half B. A to C is minus 3A plus 3 over 2b. Let's take out a factor at the moment of 3 because it looks quite similar. So we'll take out a factor of 3 and then we'll have minus A plus a half B. And actually this vector was exactly the same as what we had from AM. So a really nice way to write our answer would be writing this as 3 brackets, and just changing back to my red pen, minus A plus a half B, that was our AM vector. So what we've shown is that A to C is 3 lots of A to M. That means they must be parallel. But actually, because they have the point A in common, they must lie on the same straight line. So we are actually done here at this point with a little bit of explaining.